Welcome back. We are now focusing on electric circuits. We are going to solve exam related problem on electric circuits, a section that needs a lot of interpretation, especially the tracing of the flow of current, which holds a key in resolving problems related to this section. We have got a recent question paper here, very good. Question number 9. The statement is just saying a battery with an internal resistance of 0.5 and an EMF of 24 volts is connected to 4 resistors. Remember, in a circuit we have got a maximum of 5 resistors, including the internal resistance that is stipulated in the examination guideline. A closed switch, a high resistance voltmeter with 22.3 volts, an ammeter negligible resistance as shown in the diagram below. Remember, the voltmeter will read 22.3 when the current is flowing, when the switch S is closed. The resistance of the connecting wires must be ignored. Good. And then now we are given this type of a circuit. I hope you can see. As per the statement, the first question, they say to us, explain the term EMF of 24 volts with reference to work done. Normally, the EMF, by definition, is the maximum energy supplied by the battery per coulomb charge or per unit charge. Now in this case they say adjust that definition to the work done, and that you must not talk about energy but the work done. We are guided by this formula which help us in defining the EMF, which is V equals to W over Q. This is the formula that we learned since grade 10. Now this 24 volts, meaning that will be 24 joules of energy over 1 coulomb. Now if we put it in weights, we'll say now 24 volts will be 24 joules of work done. No longer energy, of work done per unit charge or per coulomb charge. You can say unit, or they use the word per coulomb charge. You will be correct. Fine. And then now 9.2, they're saying to us 9.2.1, calculate 9.2.1, the current in the 3 ohm resistor. If you look at the circuit, the current passing through the 3 ohm resistor will be the current that is registering on the ammeter. That indirectly the examiner is in need of the current flowing in the circuit. Now according to the given information, now we use the formula that is EMF equals to V external, which is the one that represents the voltmeter plus IR, or learners, you can use also the internal resistance as the V lost divided by I. So there are many ways to deal with this. EMF, according to this one, is given as 24. The V external when the switch is closed is 22.3, plus the current is the one I'm calculating, multiplied by 0.5. Therefore, the current will give me, in this case, 3.4 amperes. If we use the calculator, that is 9.2.1, 9.2.2. Just telling us to say calculate the power dissipated in the 18 ohm resistor. 5 marks mean that you'll use more than one calculation in dealing with this. Now if you look at the circuit here, if you want to calculate the current is between the 18 ohm, we must know the voltage across 18 ohm. That's the easiest one. So remember, the voltage in the parallel combination is the same. The voltage across 6 ohm, the voltage across R, the voltage across 18 ohm is the same. Okay, fine. Therefore, what do? We know the current, total current in the circuit. What we can do, we know that the voltage across 3 ohm and the voltage of the parallel will give us 22.3. Can we find the voltage across 3 ohm? Yes, we can do that. The voltage of the 3 ohm resistor will be IR, which will be, the current is 3,4 multiplied by 3, which give us 10,2 volts. Now we need the voltage across the parallel, remember. Therefore the voltage across parallel will be the V external, which is the total voltage of the external circuit, minus the voltage across 3 ohm. This will give us 22.3 minus 10.2. Therefore the answer will give us 12,1 volt. Easy. We know the voltage of the parallel, then we know that the voltage across all the resistors in parallel combination is the same. Therefore we can now find the power. Therefore the power dissipated in the 18 ohm resistor will be the voltage of the parallel divided by the 18 ohm, which will be 12,1 squared divided by 18. Therefore the answer here will give us 8,314 watts. That is the power dissipated that we wanted to calculate. In this case, we get 5 marks for doing that. Very good. And then let's go to the next question. The next question says, calculate the current in the resistor R. Resistor R is part of the parallel combination. Therefore, we know that the voltage in the parallel combination is the same. Therefore, we can calculate the current then across 6 ohm and 18 ohm. If we know the current flowing through 6 ohm and 18 ohm, we know that the total of that parallel combination will be the same as the total current, which is 3.4. Now we can calculate, obviously we know the voltage in the parallel combination. In this case, as given in the diagram, you can see, then we are going to calculate this, which is 4 marks. Let's start. We now calculate the current through 6 ohm resistor. The current through 6 ohm resistor will be now the voltage of the 6 ohm divided by the 6 ohm itself. The voltage is the same, will be 12.1 divided by 6, which give us 2.02 amperes. Again, we find the current through 18 ohm also, which will be V over R, V of the parallel over R, if you want to be explicit, which will be the same as 12,1 divided by 18. This will give us 0.67 amperes. Use your calculator there to confirm that total, that quotient. Now once we know the current there, then now we can know that the current through R will be now the total current, I total, minus the current through 6 ohm minus the current through 18 ohm. Therefore this will be, the total is 3,4 and the 6 ohm is 2.02 and the 18 ohm is 0.67. Then if you use your maths, you will find that now the total is 0.71 amperes. That will be the total current that flows through the R. So that is 9.2.3. And then we go to the last question, that is 9.3. Now they tell us to say, will the power dissipated in the 18 ohm resistor increase, decrease, or remains the same in this case? So or the statement prior that they say resistor R is removed. If you remove resistor R, remember, the fewer resistors in parallel, the greater the total resistance of the circuit. Therefore, if you do that, what will happen to the power dissipated there? Therefore, now we know that if the total resistance of the circuit is increasing, means that the current in the circuit, total current, will decrease. But in the parallel combination is different. You must note that to say the current flowing through 6 ohm and the current flowing through 18 ohm will increase. Yes, the total current in the ammeter will decrease, but the current flowing through here, it was very small, now it will just go up a bit. So then if the current through 18 ohm is increasing, then it means that the power also dissipated there will increase, and that the first answer will be increase. I hope you understand my explanation to say when resistors are connected in parallel and you remove or increase the total resistance in that circuit where there's a parallel combination, or you remove one of the resistors, the current flowing in the remaining resistors will increase. So the total resistance of the circuit will increase and the total current will decrease, but the current in the remaining resistors in the parallel combination will increase. In this case now, that's the first mark. The second 2 marks will be on the explanation. Then you tell the examiner to say, fine, the total, R total of the circuit increases if you remove that. And then the second mark will be now the I total, current total in the circuit will decrease. Fine. And then therefore if the current in that one decreases, then but this one, the current through 6 ohm and the current through 18 ohm will increase. If this one happens, then it means that now the power dissipated there, if you are using the formula P equals to I squared R, then the power will increase. Or someone can use P equals to V squared over R. In that case now, I will say if the total resistance of the circuit increases, the total current in the circuit will decrease. That will let into this one to say if you are using the formula of V external plus IR, therefore if the total current in the circuit, this will also decrease. And if this one decreases, then the V external will increase. If the voltage of the whole circuit increases now, it's more than 22.3 as it was given. Therefore, it means that also the voltage of the parallel will also increase. Therefore, if you are using the formula of P equals to V squared over R, therefore it means that the power will also increase if you are following this route. So there are many ways of dealing with this question. So as long as you know the explanation thereof, then that will help you a great deal. Thanks a lot. Until we meet again in the next explanations, I hope this enlightened you that circuits are not that difficult. You just need our interpretation, especially when dealing with parallel combinations. So until next time, bye.